So yesterday we looked at the period pretty quickly, and then the last thing there that we did not get to was this period when you have phase shifts. Okay, so that we need to look at, and then we needed to do some examples. So when your period is not 2 pi, it affects the phase shift. So this would be a case like when I have, now I realize we haven't done much practice with this, so you may not remember, but if I have y equals sine of 2x plus pi, like that, we were learning at the end of class yesterday that to find the period for this, I would do 2 pi divided by the number that x is multiplied by. So divided by 2, right? So the period for this example I just put here would be pi, right? So if the period is anything except for pi, it affects the phase shift, and remember that phase shift is you're moving left or right, okay? I did not, whenever we were graphing quadratics and cubics and all of that stuff, I never gave you one where you had a horizontal compression or expansion and a shift left or right. I never gave you any of those that you had to do both. Because they're a little complicated and we don't really need to worry about them too much. However, with the trig functions, this happens pretty often, that you have both a change in your period and a phase shift left or right. So, it's a little different than what we've seen with the other problems before, but figuring it out is not too terribly bad. So, if I have an equation like this, y equals sine of kx plus c. Here, k and c are just numbers. Then, to find the phase shift, it's going to be c over k in the opposite direction. So you take, where normally I would think that this one right here would be to the left pi. Instead, because you got that phase shift, it would be to the left pi over 2. So you've got to divide it by this number here in front of the x. Okay. Let's look at these examples here. We're asked to find the period and the phase shift. Okay. So for cosine of 2x plus pi, very similar to the one I just did. For our period, yeah. I need to get some more from back there. So period is 2 pi divided by, we're using this number right here in front of the x. So that is 2. So our period here is pi. And then if I look down here, I've got the plus pi, which makes me think to the left pi. But because I've got this number out front, I've got to divide by that number because that affects the phase shift. So I have to divide by 2. So it's actually left pi over 2. Yes? If it's just x plus pi, then that x is like it's got a 1 in front of it, so you don't have to divide by anything. So it would just be left pi if there were no number in front of your x there. So when you don't have a change in the period, it's just normal, left or right, whatever amount is there. It's whenever we've got this number in front of the x that it causes problems. Okay, you'll notice here, no difference. I should have made a different example right here. I wasn't looking down the page very well. But no difference whether it's sine or cosine. We do the exact same thing for sine and cosine here. It's going to look a little different when it's graphed, which we'll see later. But as far as the shifts, it's the same. Okay? You're going to take that the squiggle that we graphed yesterday, right? And you would, the period being shorter, being pi instead of 2 pi, we'd squish it in half as long as it was. So that would mean that it would look, you know, like that more. It's going to be like it's not like an accordion, like you're squishing the accordion in. It makes all the little waves a little bit smaller. And then we'd take it after we squish it, we'd shift it over to the left, that pi over 2. And at first we're just going to look at knowing what has happened. So just describing what has happened, not necessarily graphing it. And then later, if we get time today, we're going to start graphing, and then we'll finish graphing tomorrow. Which I've actually decided I'm not going to make you guys graph these by hand this year. I usually make you guys graph them by hand, but I think that I'm just going to give you problems where we have to look at graphs or make graphs on the computer, not really graph them by hand. Because I've decided with technology these days that you don't really need to know how to graph them by hand so much. So we're going to try it and see how it goes. What we've got here is we've got sine of 1/3 x plus 9. So the period, the normal period for sine is 2 pi, right? 2 pi is all the way around the unit circle. So we will divide that by this number right here in front of the x. Okay, so I have 2 pi divided by 1/3. Right, flip and multiply because I do not want you to leave me complex fractions. Nobody knows what 2 pi over 1/3 is. It's too complicated, right? That would be like if I asked you how old you were and you told me that you were 30, or if you were, like if you said that you were 8 divided by 1/2, right? 8 divided by 1/2 is 16. But if you told me you were 8 divided by 1/2 when I asked you your age, that would be ridiculous, right? So don't leave complex fractions ever because nobody knows what those mean. So 2 pi times 3 over 1, which is going to just be 6 pi. Okay, questions on that part? So that gives us our period. Now we need to look at our phase shift. So the phase shift looks like it should be to the left 9 units, right? That's what it looks like it should be. But we've multiplied by a number here. So we have to divide by 1/3 there. And once again, we can't leave it 9 divided by 1/3. So we're going to change that to, let's go up here, 9 times 3 over 1. Dividing fractions easy as pie. Flip the second and multiply. And then that's like 9 over 1. So we just get 27 over 1. But that's 27 here. So we have a period of 6 pi. We're moving to the left 27. Okay, questions? Alright, I'm going to add in, before we do those next examples, I'm going to add in a slide here. I really don't need, well, I guess I can type in the, alright, I need to add an equation. So, alright, so, if I have y equals a times sine of bx plus c plus d. Okay, so if I have that equation there. Alright, so this is, and it would not, I guess we should add or. Or if I had this same equation, but instead of sine, cosine, then this will always be true. The amplitude, okay? Amplitude, that's how tall it is, right? So that is stretching it out, vertical stretch or vertical expansion or compression. What letter gives us our amplitude? A. Okay? So the amplitude is whatever number we have multiplied by that sine or cosine. The midline. Okay, our midline. The midline's that line that runs through the middle of the graph. So it's going to change when we move the graph up or down. Right? So the midline is a horizontal line, so we call it y equals. And what letter would it equal if we were looking at either one of these? D. Okay? So that number added on the end, that's your midline. Your period, okay? How are we going to find the period? It is 2 pi, 2, where's pi? There it is, 2 pi over, gosh, this equation editor is not that great, 2 pi over b. We would divide it by this number right here in front of that x. And then the last thing is our phase shift. Okay, what would we do to find our phase shift? C divided by B. And it's going to be, I'm going to put a negative there to remind me that it's the opposite direction. So if I have a positive C, it's going to go to the left C. If I have a negative C, it goes to the right C. Negative C over B. So that sort of summarizes everything that we would have for these examples. Okay? So, let's look at some examples now. Okay? So for all of these, we have to tell the period, the amplitude, the phase shift, and the vertical shift for each function. Actually, let me also change that. Instead of calling it the vertical shift, let's call it the midline. So where yours says vertical shift, let's say midline. Okay. So if we look at that first equation, Christian, what would the amplitude be? It would be 3. Okay. Let's do midline next. I think it's the next easiest. Okay. Dylan, what would our midline be? Okay. And we're going to say y equals 4 because that is the equation of a horizontal line. Okay. Now, we don't have anything else different about cosine or sine, right? Here, nothing has changed. So what we'll say for our period, every equation has a period, or every trig equation has a period. So we always want to give the period even if nothing has changed about it. So Jonathan, what is the period for this one? What do you think? Okay. It can't be 2 pi over cosine because cosine is just like a function. But there would be our parentheses if we had them, right? So in those parentheses, if I tried to make it look like that slide that we just did, then what number's in front of the x? A 1. What number is added to the x? Nothing, so it'd be 0, right? If we're wanting it to look like that other function. So if you just have an x there, the period does not change. So the period for sine and cosine is 2 pi, right? It's always 2 pi, unless you have a number here. Thank you. Okay, so it's just 2 pi. Or you could think of it, if you're thinking about the equations and the rules, if you divide it by 1 here, 2 pi divided by 1 just gives you 1, right? So our period is 2 pi. You always have a period. Even if it has not changed, then it's 2 pi. But whenever it comes to phase shift, do we have a phase shift here? Phase shifts are shifts left or right. We do not, because there's nothing added or subtracted. If it was, it'd be 0, and if you move something left 0, you didn't move it, right? So this has no phase shift. Okay, let's do this. I think it's a good idea as we go along here to look at the graphs. Actually, I got this bookmark the other day. Come on. All right, so if we graph y equals 3 cosine x plus 4, and let me change my axis here. So negative 2 pi and 2 pi and pi over 2. Okay, so if you graph this, we can see, actually let me also graph just cosine x. Oh, oops. Y equals x. We can see that the amplitude is higher because it's more stretched out, right? And it's also been moved up, where the midline here was at the x-axis. Now, if you look at the midline, the highest point right there is at 7. The lowest is at 1, so halfway between 7 and 1 is right here at 4. If we graph that y equals 4, that'll show us the midline there, right? That's that midline. So that's moved up and then stretched out. Okay, so that's I think it'll just be good for us to look at what that looks like as we go through. So we'll look at these on the graph. All right, so if we go back, let's look at the next one. Okay, let's see. Christian, what is my amplitude for number 2? 1/2. Okay, and Gabriel, what is the midline? What's that? It is not 3. Okay, the 3, that's on the inside of the parentheses, right? And the 3 is going to move it left or right. The midline is that line in the middle of the function. The only way moving it left or right doesn't really change anything about the function, right? The only thing that changes it is moving it up or down. Okay, so it's just the x-axis there, right? And the x-axis, when we have to give an equation for it, it's the equation y equals 0. Okay, so if it has not moved up or down, it's just going to be y equals 0 because that is the x-axis there. The function always has midline, even if it hasn't changed. So if it has not moved up or down, the midline is going to be y equals 0. Okay. Okay. Let's see, Brian. What about the period for this one? Okay. Just 2 pi, because the number right here in front of x is what changes our period, because that would be a compression or an expansion. So it's like an accordion. It squishes it in and gets it all tiny, or it stretches it out. But we don't have a number there, so our period is going to stay the same. So it's just 2 pi. And then our last is our phase shift. Okay, so Shane, what kind of phase shift do we have here? Okay, it is right 3. We go the opposite direction, so since that's negative, it's going to be positive. We didn't have to divide by anything here because we don't have a number in front of x. Or if we did, it's a 1, so it stays the same. All right, let's look at this graph real quick. If we graph, let's see, what was it, 1/2, was it sine of x minus 3? Is it sine or cosine? Sine, okay. If I got that right? Okay. All right, so let's get rid of that line right there. We might want to get rid of sine. Okay, so this is, actually let's do this. Y equals sine x. Let's get rid of this one first. Make this one y equals sine x also. Alright, so this is sine x, right? When we put that 1/2 in front of it, see how it squishes it down? Right? And then, when I put the minus 3, it's a little hard to see that. Let's do this. I'm going to do minus a. And then let's add a slider. So if we watch this, watch what happens to the graph. Right now a is 1, right? And I want a to be 3, so as I slide this over, right there, well, I'm having a hard time getting there. There we go. It's at 3. So you can see that it slid over. It's a little hard to tell when these graphs have been slid left or right because it looks the same, right? It just repeats itself because it almost looks like maybe something flipped there instead of a slide, so that slider kind of helps you see what happened there. So this is what that looks like on the graph. Okay, let's do some more. Let's get a little more complicated here. Okay, so on this one, we've got y equals 2 sine of 2x plus 4. So, let's see. Look, Norman, what is my amplitude? Very good. Then let's do our midline. So, Levi, what do I have for my midline? Okay, 0. So it's going to be y equals 0. We have not moved this up or down any, so the midline is not going to change. Jenna, what about the period? 2 pi over 2. Very good. We're taking 2 pi. We divide this number right here because that is our horizontal stretch or strength. So that is going to give us a period of pi. And then, Dylan, what about our phase shift? The 4 over 2 sounds good. Are you sure it's to the right? It's going to be left because you got to go opposite direction. So left 4 over 2 because it looks like it should just be left 4, right? But you got to divide by that number that's in front of the x if there is one. We haven't seen that yet because the last phase shift we didn't have a number in front of the x. So we would have this is really just left 2. Okay, so let's look at that on the graph. So this one's a sine, right? So let's take it one step at a time like we did with the last one. Let's look at having that 2x first, okay? That 2x inside, that is squishing our accordion, right? So this blue graph is sine. And so notice for this to repeat, it goes all the way out to 2 pi. But here, we've got it squished in and it's half as long, right? So we're squishing our graph in. Very mathematical term there, to squish. Then we had 2 out front as well, right? Is that right? Okay, so that 2, that's our amplitude. That stretches it out, makes it taller. So whereas 1 was the highest point this ever got to, now it goes all the way up to 2, all the way down to -2. All right? And then let's do a slider again for this. So if we had, this would be just at 0 where there's nothing added there, but we added 4. So as we increase that, it's moving it to the left 4. So you can see it slide that direction 4. Questions? It cannot, because if you had a 0 right here, watch what would happen. It just turns into a flat line, because 0 times all this sine stuff right here is 0. So it would just be the line y equals 0. If there's nothing there, it's like there's a 1, so the amplitude is 1. Okay, so if you don't have anything there, it would be 1. Good question. Okay, all right, here we go. All right, so y equals cosine of 3x minus 6 plus 4. So that was a really good question, considering the next one coming up. For this one, Gabriel, what is the amplitude? It's going to be 1, right? Because there's nothing in front, so it's like there is a 1 there. You always have an amplitude. The only thing you may not have is a phase shift, right? You always have an amplitude, always have a midline, always have a period. But the phase shift, you might not have one of those. All right, so our midline, Jordan, where would our midline be at? Perfect. Y equals 4, because this 4 right here moves that graph up 4. Let's see. Wendy, what about our period? 2 pi over 3. Very good. 2 pi over 3 does not reduce. Just leave it 2 pi over 3. Okay. And then Cameron, what about our phase shift? Okay, it is to the right, and how much? 2. And how'd you get 2? 6 divided by that 3. So I'm going to write that down just for our notes here. But you're welcome to do that in your head. Write 2. All right, so we take this number and divide it by the 3 that we have here. Okay? Questions? Let's look at that graph real quick. I love this program right here. So good. Is that one a cosine or sine? Cosine. All right, so let's start with cosine. Oh, wait. That's the x there. All right, so what do we have here? 3. Okay, we really can't see that. Let me go here and change my step to pi over 6. Well, each one of these now, they're not labeled. Let me zoom in a little bit so it shows you pi over 6. Right, so if you notice here, as we repeat, we start at that highest point, or back up to the highest point at 2 pi over 3. Now, so there's our period. It's squished in there. And then if we put that minus 6 there, it doesn't look like much happened to it, but if we did an A there, we can kind of see it. It's here. We move it over until that A is 6. I'm having trouble getting that exactly. So that slides it over. And then we'll have a plus 4 on the end. So that plus 4 on the end just takes all of that and it moves it up. If I were to graph y equals 4, I can see that goes straight through the middle of that graph, so that's my midline there. Okay, questions on that? All right, let's see. All right, we're going to take a break from notes right now.